Alright, here's my case against macroevolution. Before I continue, all sources are in the description down below. If you want to propose a potential refutation or add on to my arguments, feel free to leave it in the comments and I'll address it if I see it in due time. If I don't see it, just keep spamming me. I'll eventually see it and I'll address whether it's an argument against or for me. Alright, so with that, let's get straight into it. Case 1. Chromosomal differences. While chromosomes certainly aren't the only factors driving reproductive capabilities, we can rightfully assume that chromosomes play a huge role in the creation of life. For organisms to mate, they need not share the same chromosomal count. However, to be fertile, animals must have the same amount of chromosomes. For instance, the mule, a hybrid between donkeys and horses, is simian fertile, with chances of a mule having offspring in a literal 1 in a million chance. This is largely believed to be attributed to their differing chromosome count. However, hybrids such as the cross between a cow and a buffalo, which share the same chromosome count, are indeed fertile creatures. Differences in chromosomes seem to have a tremendous effect on reproduction. Even in humans, people who suffer from Down syndrome do so because of one extra copy of chromosome 21. Another factor is indeed genetic similarities. If the genetic mapping of organisms are very similar, like in the case of the cross between the horse and a donkey, it may be possible for the resulting offspring to be a hybrid. To sum up the basis for this case, I would like to finish by saying that differences in not only chromosomes, but factors of the genetics of the species in question can determine if it is a hybrid. However, differences in chromosomes can cause severe effects that have proved to be nothing but detrimental, leading to infertility and severe complications. Without a close genetic similarity, there is no way a hybrid can be made. Now let's go into point 1. No solid evolutionary link between the modern human and primates. Before we advance any further, I must address a key point. Just because two animals have similar physical characteristics does not mean that they can reproduce with each other. As I stated before, a close genetic similarity must be maintained for a creature to be able to mate with another creature that doesn't have the same chromosome count. Even for silver beams and common beams, which look extremely similar, they can only produce infertile hybrids. That being said, despite similar skeletal structures, Neanderthal lineage should be traceable through the human's male's Y chromosomes for suspected lineage to be confirmed. Why that chromosome is a question you may ask. The answer is simple. The chromosome that is transferred from father to son is a direct copy from the father. If Neanderthals are humans' missing link between the lineage for primates and current humans today, some Neanderthal DNA should be in the Y chromosome. Problem is, it isn't. There isn't a solid link due to this fact. By the way, before you parade the fact that Neanderthals share around 20% of genes with humans, dogs share 25% of their genes with humans. This should point to common design, not evolution. If dogs have more in common with humans than our supposed close ancestor, science has a lot to explain. In closing to this point, the three main key factors are: to become a hybrid, two species must be closely similar from a genetic standpoint and preferably share a chromosome count. Seeing that Neanderthals, the supposed link between primates and humans, have less in common with humans than dogs do, we can assume they are not from the same lineage. There is no solid proof in the Y chromosome of males that the first humans had paternal ties to Neanderthals. Just because two organisms have similar physical structures does not mean they are suitable mates. Which will lead me into my next point. Point 2. Circumstances needed for a smooth transition from chromosome counts. We've already established that the supposed missing link between primates and humans are not even close to being related to the human race. However, for the sake of argument, let's assume that there's a string of fossils, even though the fossil record isn't reliable, I'll explain why if this video gets a part 2, that show an animal with an extremely similar genome to humans and claim it to be another missing link. There is one question that will be left unanswered. How did the creature transition from differing chromosomal counts? One theory may indeed be that their genomes were closely similar so they could mate. However, I'd like to refer back to my previous example. Horses and donkeys have different chromosomal counts, which are theorized to make the mule they conceived with a 1 in a million shot at being fertile. So, if we assume that the genomes of this theorized missing link were close enough for hybridization, the chromosome count would likely restrict the offspring's ability for reproduction and possibly other natural biological processes. Now that we established the other theory is unlikely at best, the next possible theory would be that there were multiple animals with that mutation and that they likely bred with one another. However, not only are changes in the chromosome count extremely touchy and would lead to major changes that could be very detrimental, for example, Down syndrome, which I brought up earlier, it would be unlikely for the exact same mutation to happen twice in one generation and for the Adam and Eve of this new species to find each other and choose to mate with one another. Also, if this new species differ in appearance or other strengths such as hunting for food, fighting, dominance, etc., then it would be likely they would die to nature or other people of different species that would likely cohabitate with them or compete against them for resources. We can agree that mutations are definitely random in nature and aren't on a designated path. For this theory to work, every or close to all mutations would have to benefit the new creature so it could stay ahead of its competitors, which goes against the idea that mutation is random and could hinder the organism instead of helping it. Also, it is improbable, close to impossible, for a string of mutations which would cause a change in the chromosome count to affect two offsprings near the same area in the same generation. To close this point, three main factors must be addressed. Different chromosome counts lead to adverse effects in reproduction, which will likely hinder any offspring that are conceived. Multiple animals with these special mutations existing in the same generation would be improbable to impossible. These sudden new organisms may kill or simply outperform I read that wrong. These sudden new organisms may be killed or simply outperformed by the old species if one or more mutations work to hinder them instead of help them, which makes this theory illogical, since every mutation would have to help the organism, while mutations are indeed random. Okay, thanks for listening. If this video gets 10 likes, I will make a part 2 about my problems concerning the fossil record. And thank you for watching. Have a great day. See you later. Jane.